Hello, people. How you guys are doing? Welcome, everyone. So today we are going to do very important topic. It's an interesting topic and important topic that we are going to do today. I should get something where, wait. So as I said, it's an interesting topic. Where is my pen? How you guys are doing? आज हम लोग करने वाले हैं power screw. Today we are going to do power screw. By the way, this is English session, na? So we are already done with belt friction. Now we are going to do power screw. We are in the third chapter of engineering mechanics. We are in the third chapter of engineering mechanics, and we started with laws of dry friction, and then after laws of dry friction, we went to what? Application number 1, that is sliding. Then application number 2, that is toppling. Then application number 3, that is belt friction. And now we enter into application number 4. Application number 4 is very interesting. Application number 4 is regarding power screws. And today, for next 120 minutes, we are going to become a master of power screws. Next 120 minutes, and we will do a mastery at power screws. So let us start building the concept. First, there are certain prerequisites that we need to understand. Once we understand those prerequisites, then we will be able to understand power screws and the analysis of power screws. So try understanding. There are certain, first we build some prerequisites, some pre-concepts. One such pre-concept is the concept of resultant reaction. So far you have seen that whenever you are applying, dhyan se samajhiye. Be very attentive. So far we have always been dealing normal reaction and friction force separately. For example, this block is resting at the floor, and then we are applying a force here. So if we are applying a force here, we said that what will be the free body diagram of the block? Free body diagram of the block will be the force has been applied, W has been applied, then normal reaction will be there, and friction force will be there. If I increase applied force F, what will happen? If I increase applied force F here, what will happen? So this normal reaction is there and this frictional force is there. Now suppose I apply applied force, I increase the applied force F. If I increase the applied force F, and then W is there, and N will not change because W will not change. So if I increase the applied force, naturally the resistance will increase. Friction force, particularly static friction, is a self-adjusting phenomenon. If there is no tendency of motion, there is no resistance. If you apply 50 Newton, it applies 50 Newton. If you apply 80 Newton, it applies 80 Newton. If you apply 100 Newton, it applies 100 Newton. But there is a limit. If I increase applied force even further, if I increase applied force even more, what will happen? If I increase applied force even more, naturally n is not going to change. Normal reaction will be same. But since I increased applied force, the frictional resistance is going to increase. So does this frictional resistance keep on increasing forever? Somebody come forward and tell me. Does this frictional resistance keep on increasing forever?
No, sir. No, sir.
If I keep increasing my load forever, would this frictional resistance increase forever, 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 forever? Somebody
No,
please come forward and tell
no,
that
sir.
would
It will not.
this frictional force keep on increasing forever?
No, sir. It increases at a certain limit. After that, it will decrease.
Good evening, good evening, good evening to everyone who have joined from YouTube. This session is going on live, so I'll just keep an eye on YouTube session also in meanwhile. Good evening, everybody who is live from YouTube. So if I increase the friction force, if I increase the applied force, I know that frictional resistance will increase. If I increase the applied force again, frictional resistance will increase. But you know there is a limit. There is a limit. Beyond the limit, frictional resistance can't increase. So once I reach to the limit, then frictional resistance is not going to increase. So let's say that we make one more diagram representing that limit. Okay. Let's make that one more diagram representing that limiting case. So if on the same block, I keep increasing the applied force, a limit will be reached. And once a limit will be reached, n will not change. I'm saying it again. And once a limit is reached, then frictional force will not increase anymore. At that time, frictional force will be equal to maximum possible value. So every surface has a limit. Every surface is having a capacity because roughnesses are logged. So you need certain level of force to break those roughnesses. To break those roughnesses, you need certain level of force. Certain level, once you reach, then only the roughness will be broken. And after that, no roughnesses are logged, so no resistance will be there. Roughnesses are not logged anymore, so resistance will not be there. At that point, we call it limiting friction. At that point, we call it limiting friction. This is called as limiting friction. This is something we call limiting friction. Cool. Now, so far we have been dealing things like this, but now we are going to talk in terms of resultant reaction. So normal reaction is there and frictional force is there. Normal reaction is there and frictional force is there. Normal reaction is there and frictional force is there. And we know then frictional force is having some limiting value. It cannot reach beyond that limiting value. It cannot go beyond that limiting value. Now you think about the resultant of normal reaction and friction force. Normal reaction is the reaction which is perpendicular to the surface. Friction force is the reaction which is along the surface. Now you think about resultant reaction, normal and friction force. Now you think about resultant reaction, normal and friction force. Now you think about resultant reaction, normal and friction force. Now you think about resultant reaction. Do you notice something is regarding this resultant reaction? Not only magnitude is changing, but there is one more thing changing here. Regarding this resultant reaction in picture 1, regarding this resultant reaction in picture 2, regarding this resultant reaction in picture 3, and regarding this resultant reaction in picture 4, do you notice something apart from magnitude? There is something changing. Congratulations sir for 4,000 subscribers. अभी तो ये शुरुआत है सफर की, उड़ाने अभी और भी बाकी हैं. आप सबका प्यार रहा. If your love and affection and trust and faith continues, this will go to 40,000. And there are certain, like, physics also to be started, and there it will go 4 lakhs. So thanks for everybody. I mean, faith that you have put, all of you. मैंने आपको मैसेज किया था, अंश बेटा मिस कॉल ड्रॉप कर दो प्लीज. मिस कॉल ड्रॉप कर दो. जितनी भी मिस कॉल्स होती हैं मैं 90% ऑफ द टाइम्स उनको कॉल बैक जरूर करता हूं. सो नाउ यू टेल मी, R1 का what else is changing? You notice
Angle,
that
sir.
R1 not only magnitude is changing, but its angle from normal reaction is changing. Its angle from normal reaction is changing. Its angle from normal reaction is changing. Its angle from normal reaction is increasing continuously. And naturally, after this last picture, angle of normal reaction angle of resultant reaction can not increase beyond one final maximum value. Sudhir Babu has answered angle is increasing. Exactly. So angle of resultant reaction is increasing. This angle is going to give you an idea. This angle is going to give you an idea. This angle phi here, this angle phi here, this angle phi here, this angle phi here is going to give you an idea of how much friction is present. This angle will give you an idea of how much friction is present. Look, when friction is lesser, angle is lesser. When friction has become more, you applied more force. You applied more force, and friction became more. Friction became more, then resultant reaction became little more horizontal, angle increased. You applied little more force, even more frictional resistance got induced, and resultant reaction became more horizontal, more towards horizontal, and angle further increased. You applied even more force, friction force increased to the maximum possible value for one given pair of surfaces. And notice that after this, neither friction force can increase nor this angle can increase. This angle gives you an idea of how much friction is present. This angle of resultant reaction from common normal, this angle of resultant reaction from common normal, this angle of resultant reaction from normal reaction, which gives you an idea of how much friction is available currently between the surfaces, is defined to be friction angle. This angle phi, my dear friends, this angle phi of resultant reaction, this angle phi of resultant reaction from normal reaction or common normal from normal reaction or common normal is following the increasing frictional force values. As you are increasing the applied force, friction force is also increasing, then corresponding normal reaction, corresponding angle is also increasing. So the angle phi of resultant reaction from normal reaction or from common normal which gives an idea of how much friction is present, which gives an idea of how much friction is present, how much friction is present is known as friction angle, is known as friction angle phi. When friction force reaches its maximum value, when friction force reaches its maximum value, when friction force reaches its limiting values, when friction reaches limiting maximum value, when friction reaches limiting maximum value, which is mu s multiplied by n, which is mu s multiplied by n, then friction angle also reaches its maximum value. Then friction angle phi also reaches its maximum value. Friction angle phi also reaches its maximum value, phi s. This maximum value of friction angle is known as, this maximum value of friction angle is known as angle of repose. This maximum value of friction angle, we have given a name to it, and that name is angle of repose. This maximum value of friction angle is known as angle of repose, is known as angle of repose. Do remember this term, angle of repose, angle of repose, angle of repose. This maximum value we call as angle of repose. So can you now tell me what is the formula, general formula of friction angle, and what is the formula for angle of repose? What is the formula for general formula for friction angle, and what will be the formula for angle of repose?
Sir, tan theta equal to mu.
Theta.
So what is the formula? I
Theta
can
is
very
equal
clearly
to
say that tan phi can be written as friction force upon normal force. So I can write tan phi is equal to friction force upon normal force. This is how I can calculate phi value, which is friction angle. So phi value can be calculated, and that phi value is friction angle. Which can be calculated as tan inverse friction force upon normal force. But how would you calculate angle of repose? Angle of repose you are going to calculate. How would you calculate angle of repose? For angle of repose, you need to put maximum value of friction. For angle of repose, you need to put maximum value of friction. So when friction angle reaches the maximum value, we have tan phi s. And at that time, friction force has become mu s into n upon normal reaction. Friction force is having its limiting value, mu s n upon normal reaction. So n and n, they get cancelled, and I get n and n, they get cancelled, and I get tan phi s is equal to tan phi s is equal to mu s. Now, this is an important formula. Make a note of it, not only in your notebook, but also in your mind. This one is an important formula. Please make a note of it, not only in your notebook, but also in your mind. Make a very intense note of it. So make sure that you have noted down this formula. So general formula of friction angle is this, but then we have angle of repose. General formula of friction angle is known, and then angle of repose tan inverse mu s. This was when we are trying to learn power screw. This was the first prerequisite that we should know about friction angle. If we are trying to learn power screw, we should know friction angle. So now, if there is any doubt, go ahead, ask it so that we can move ahead. Friction angle is done. All of you clear about it? Once all of you are clear about it, let us go ahead and do the next thing. So this has been saved. Now, friction angle is known. We have very clear understanding. Just in case if there is any doubt, let me very quickly revise, very quickly recapitulate that people, when we apply no force, naturally we will have no friction. When we apply little force, there is little resistance. When we increase more applied force, more resistance is there. Even more applied force, even more resistance is there. Even more applied force, even more resistance is there. But this resistance does not increase beyond a limit. That limiting value has been found as mu into n, and that limiting value is the maximum friction that can be present between a pair of surfaces. Between a pair of surfaces, that is the maximum value that can be present. Okay, mu s n is the capacity of the friction force that can be present between a pair of surfaces. Now, one thing we notice that as the friction force becomes more and more and more and more, also the angle of resultant reaction becomes more and more and more and more. Also, the angle of resultant reaction becomes more and more and more and more. If the angle of resultant reaction becomes more, we notice a correlation that friction force less, this angle is less. Friction force became more, this angle became more. Friction force became even more, this angle became even more. Friction force became maximum, this angle also became maximum. So the angle of resultant reaction from normal reaction gives you an idea of how much friction is present. And therefore, people named it friction angle. That's why people named it as friction angle. Okay. Why do you call it friction angle? Because it's give you angle that gives you an idea of how much friction is present. The value of angle and less friction. More angle, more friction. Even more angle, even more friction. Even more angle, even more friction. Okay. So you can calculate that value. Naturally, when friction force has become max, then the angle also has become max. And this max value of angle of friction is known as angle of repose. Maximum value, limiting value of friction angle is known as angle of repose. Angle of repose, in the limiting picture, we can calculate angle of repose tan phi s. In this limiting picture, you can calculate angle of repose tan phi s is equal to maximum value of friction upon normal reaction, and n and n get cancelled. So you are left with only mu s. You are left with only mu s. You get phi s is equal to tan inverse mu s. Phi s is equal to tan inverse mu s. ध्यान से समझियो, बहुत ध्यान से समझियो. Once you have understood friction angle, we will go ahead to our next concept. We will go ahead to our next concept. And the next concept is actually something that you have already studied. So our next concept is that we are going to solve certain problems. Our next concept is that we are going to solve problems. Yes, you will understand only through solving problems. So tell me, what is the score, people? Tell me what's the score?
16, sir.
Tell me, what's the score? What's the score?
16. Sir, 16.
Somebody please tell me.
16, sir. 16, sir.
Sixteen. So as a 16th problem, let's say we have an inclined plane and there is a block kept over it, and I want to move that block up the plane by applying a horizontal force. By applying a horizontal force, P, I want to move that block up the plane. So I just want you to calculate, for if the inclined plane angle is theta, how much force will be required? If the inclined plane angle is theta, how much force will be required to move the block up the plane? Calculate, determine, find, calculate, determine, find force P, or minimum force P, minimum force P required to just move the block up the plane. Required to just move the block up the plane. Determine the minimum force P required to just move the block up the plane. Now, this is not a problem related to power screw, but you will not understand power screw if you don't solve this problem very carefully. Only if you solve this problem carefully, then you will have a strong foundation of power screw. So let us go ahead and try solving this problem. Try solving this problem. And how much is the force required to move the block up the plane? How much is the force required to move the block up the plane? So let's draw the free body diagram of the block. One force is P, another is W, yet another is normal reaction of the plane. And since you are trying to create an upward relative motion, naturally friction force is going to act down. And since you want to just start the motion, that means limiting condition is present. Since you want to just start the motion, that means limiting condition is present. That means limiting condition is present. Cool. So limiting condition is present. Cool. So if limiting condition is present, naturally friction force will be written as mu s multiplied by n. Now, for the purpose of convenience, I'm going to draw all these forces from one point. Let's draw all these forces from one point. So this P we have applied, and this W is there, okay, and N is available perpendicular to the inclined plane, and mu s into N is available along the inclined plane. But since tendency of motion is up, naturally, since tendency of motion is up, naturally friction will be down. Friction will be down. Okay. Now I can take either horizontal x and vertical axis, vertical y, or I can take x along the plane and y perpendicular to the plane. I'm going to take x along the plane and y perpendicular to the plane. So let's take x along the plane and let's take y-axis perpendicular to the plane. W is making the same angle from normal reaction that W is making the same angle from normal reaction that W will make the same angle from normal that plane is making from horizontal. That means theta. That means theta. And P is making theta because P is horizontal. So P is making theta from the direction of plane because P is horizontal. That is actually very clear. Why W makes theta from normal or perpendicular to the plane? Perpendicular to the plane or normal to the plane, why W is making theta? For that funda, you already know if line 1 is perpendicular to line 2 and line 3 is perpendicular to line 4, line 3 is perpendicular to line 3 is perpendicular to line 4, then my dear friends, the angle between 1 and 3 will be same as the angle between 2 and 4. The angle between W and direction of normal reaction will be same as the angle of inclined plane. Now I balance all the forces along y direction. If I balance all the forces along y direction, in y direction, I have no component of mu s n, only n is present. And in the negative y, I have w cos theta present. And in the negative y, I have p sine theta present. This is equation number 1. Now I balance all the forces in x direction. If I balance all the forces in x direction, I'm having down the plane mu s n present and also down the plane w sine theta present. Also down the plane w sine theta is present. Up the plane I have p cos theta present. My target is to calculate p-value. My target is to calculate p-value. So let us substitute n value from equation 1 into equation number 2. So I have p cos theta is equal to mu s n plus w sine theta. Now Substitute that n value. How much is the n value? N value is W cos theta plus P sin theta. W cos theta plus P sin theta. And we also have W sin theta. Now, P I want finally, so let us divide by cos theta. If I divide by cos theta, I'm going to get cos theta divided by cos theta becoming 1 and sin theta divided by cos theta becoming tan theta, sin theta divided by cos theta becoming tan theta, and here also sin theta divided by cos theta becoming tan theta. Now I take mu s p tan theta to the left side and take it common. So 1 minus mu s tan theta I have 1 minus mu s tan theta, and on the right side W is common. I have mu s plus tan theta. I have mu s plus tan theta. So I get force, horizontal force required to move a block up an inclined plane of angle theta as mu s plus tan theta upon 1 minus mu s tan theta, 1 minus mu s tan theta multiplied by weight. Multiplied by weight of the block. Now, mugging up this formula in the current form is not really advisable. Mugging up the formula in its current form is not really advisable. If you are going to mug it up like this, you will certainly forget it. You will certainly drop it out of your mind. For this only, we covered the concept of friction angle. If you know, friction angle is defined as tan inverse. Friction angle is defined as tan inverse friction force upon normal force. And what was the value, maximum value of friction angle? Maximum value, which we call as angle of repose, can be found by putting maximum value of friction. If I put maximum value of friction, I have n and n getting cancelled, and I get tan inverse mu s. So phi s is equal to tan inverse mu s. I can write mu s as tan phi s. We have already covered in this session only, we have covered that angle of friction concept. We have already covered that friction angle concept, and we have already covered that angle of repose concept in this session only. So I can replace tan phi, I can replace mu s as tan phi s. I can replace mu s as tan phi s. And then I have tan theta, and I'm going to divide by, once again, mu s can be replaced as tan phi s, and I have tan theta. Now, if you know this, great, do appreciate yourself. And if you don't know this, shame on you. What? So first tell me if you know this, know that. Tan A plus tan B upon 1 minus tan A tan B. Tan A plus tan B upon 1 minus tan A tan B is the formula of tan A minus B. Tan A plus B. Tan A plus tan B upon 1 minus tan A tan B is the formula of tan A minus B. It is nothing but the formula of tan A minus B. So you now get something to remember, which is very simple to remember. Remembering earlier version of this formula was little challenging. It would slip out of your mind, but now you can mug it up very easily. So now you can mug it up very easily. I'm going to get W tan phi s plus theta. You need to mug this formula. You need to mug this formula up. How you are going to mug this formula up, I don't know. You are going to mug this formula, that I know. How exactly you are going to mug this formula, I don't know. You are going to mug this formula, that I know. Please make sure that you remember this formula. The horizontal force required for moving W weight of block up an inclined plane theta would be W tan pi s plus theta. The horizontal force required for moving W weight up an inclined plane theta will be W tan phi s plus theta. Cool. Now we will do it. Now we will do the opposite of this problem. What is the opposite of this problem? Excuse me for 1 minute. There's very important call and I need to take it. So now we will try solving reverse of this problem. What is the reverse of this problem? The reverse of this problem is that how much force will be required to bring the block down the plane? How much force will be required to bring the block down the plane? Wait a moment. Yes. So I need to find out. I'm just going to do the reverse of this problem now. So let's do the reverse of this problem. Okay. First of all, I save this. Note down, by the way, make a note of this result. We are going to need it. So we will need it. In power SQL analysis, we will need it certainly. Now we will do the reverse of this problem, that how much force will be required to move this block down the plane. In moving the block up the plane, there was no condition. There was no restriction on the angle of inclined plane. But in moving the block down the plane, there will be some restriction available. So let's say now we want to calculate minimum required force P, minimum required force P to move the block down the inclined plane. down the inclined plane. But before we do that, please notice that there is one value of theta at which you don't need to apply any force. Block will automatically move down. And we are assuming that we have not crossed that value of theta. If there is a block kept over inclined plane, look here, then if theta is going to increase more and more and more and more and more, if theta is going to increase more and more and more and more, then more and more and more and more and more theta value, then at 1 theta, block would have automatically moved. I'm assuming that the angle of inclined plane is actually less than this limiting value. This limiting value can be proved. Actually, we have done it in class. This limiting value of inclined plane was tan inverse mu. So we are assuming that, my dear friends, the inclined plane, if inclined plane would have reached to certain angle, this limiting angle can be proved as tan inverse mu, then block would have automatically moved. You don't need to apply the force. It will itself move because of its weight. So we are assuming here, we are putting a condition here, subjected to the condition, subjected to the condition that angle of inclined plane is less than tan inverse mu. Because if you have done sliding problems, you already know that if plane angle becomes more than tan inverse mu, block will automatically move because of its weight. Due to its weight, block will automatically move. So I'm assuming that the angle of inclined plane is less. Now, what is the minimum required force to move the block down the inclined plane? Let us once again solve it using the same approach, that we are going to have this inclined plane available, and we are applying a force P, and we are also applying a force W, and we are also applying a force W, and we are applying a normal reaction N. And since we are trying to move the block downward, naturally friction force will resist upward. And since I'm interested in knowing that when motion will just begin, therefore we are having the limiting friction present. I want to apply that much force, which will break the capacity of the friction, maximum friction condition will be there. Nothing more than that maximum value can be produced. Nothing more than that maximum value can be induced. So these are the forces acting on the block in the limiting condition. Now I'm going to draw all these forces at one point. We have P present and we have W present. We have W present and we have N present. ध्यान से समझियो, बहुत ध्यान से समझियो. We have P present, we have W present, and we have N present, and we have mu s into n present. W is making same angle from normal reaction that plane is making from horizontal. I repeat for nth time that if line 1 is perpendicular to line 2, and if line 3 is perpendicular to line 4, then the angle between 1 and 3 would be same as the angle between 2 and 4. The angle between 1 and 3 would be same as the angle between 2 and 4. ध्यान से समझियो. So W will make same angle from normal reaction as the plane is making from horizontal. As the plane is making from horizontal. Now, in inclined plane problems, we generally choose x-axis along the plane and we generally choose y-axis perpendicular to the plane. Though it is not a law, you can choose x-axis in any given direction and y-axis in any given perpendicular direction, but generally it becomes convenient. Generally, it becomes convenient if I choose x-axis along the inclined plane and if I choose y-axis perpendicular to the inclined plane. बहुत ध्यान से समझिए. Be very attentive. Now, P is making some angle from inclined plane, and that inclined plane is making an angle theta from horizontal. So this angle becomes theta again. Now let us balance all the forces in y direction. If I balance all the forces in y direction, n is acting in positive y, and p sine theta is also acting in positive y, n is acting in positive y, p sine theta is acting in positive y, and w cos theta is acting in negative y. W cos theta is acting in negative y. So I'm going to get n is equal to w cos theta minus p sine theta. W cos theta minus p sine theta. Now I do sigma fx is equal to 0. Sigma fx is equal to 0 will give me mu s n is acting up and p cos theta will act down and w sine theta will act down. So mu s n is, in fact, P cos theta is acting down the plane and W sine theta is also acting down the plane and mu s n is acting up the plane. Now you replace n value, please. So I'm going to get P cos theta plus W sine theta. P cos theta plus W sine theta is equal to mu s, and replace the n value here, W cos theta minus W cos theta minus P sine theta. Now you collect all the terms having P. So if in fact, first you divide by cos theta. If I divide by cos theta, I will have P plus W tan theta. And here I will have mu s. I have divided by cos theta. So cos theta upon cos theta became 1. And sine theta upon cos theta became tan theta again. Now I collect all the terms containing P. If I collect all the terms containing P, I'm going to have 1 plus mu s tan theta, 1 plus mu s tan theta. And that side, I'm going to have W common, mu s minus tan theta, mu s minus tan theta. Once again, let us use the concept of friction angle. Once again, let us use the concept of friction angle. Let us use the concept of friction angle, that mu s can be replaced by tan phi s. Angle of repose. Today only, in this session only, we studied angle of repose. So I'm going to get P is equal to W outside and mu s minus tan theta upon mu s minus tan theta upon 1 plus mu s tan theta, 1 plus mu s tan theta. Now, mu s can be replaced by tan phi s. So let us replace mu s by tan phi s and then tan phi s minus tan theta upon 1 plus tan phi s multiplied by tan theta. If you already know, great, appreciate yourself. And if you don't know it from today. What? Tan A minus tan B upon 1 plus tan A tan B is the formula of tan A minus B. Tan A minus tan B upon 1 plus tan A tan B is the formula of 1 tan A minus B. This way, it becomes easy to remember the formula. In this format, it becomes easy to mug this formula up. So now you can mug up this formula very easily. Okay. So now we can mug up this formula very easily. Now we have done two important cases here. One, horizontal force required to move the block up the plane, W tan phi s plus theta, and horizontal force required to move the block down the plane, W tan phi s minus theta, where phi s is a value obtained using coefficient of friction tan inverse mu s, and theta is the angle of inclined plane. I repeat once again, now we have done two cases. One is, let's save this, and then we move ahead. And let me recapitulate very quickly each and everything that we have done so far. Everything that we have done so far, let me very quickly recapitulate. I started this session with the discussion of friction angle. So we started this session with a discussion of friction angle. Friction angle is this was the very first observation. Friction angle is the angle of resultant reaction from normal reaction. Friction angle is the angle of, just give me 5 minutes and then we can now finally learn power screw. Friction angle is the angle of resultant reaction from friction angle is the angle of resultant reaction from normal reaction. Observation number 1, friction angle is the angle of, if I'm applying the force F and block is having weight W, normal reaction will be there, and to oppose this applied force, friction force will be there, the normal resistance and tangential resistance. If I draw the resultant of both these resistances, if I draw the resultant of both these reactionary forces, then that resultant reaction will look like this. And the angle of resultant reaction from normal reaction is known as the angle of resultant reaction from normal reaction is known as friction angle. Observation number 2. Observation number 2, the maximum value of friction angle. Observation number 2, the maximum value of friction angle is attained when friction has attained maximum value. You know that given pair of surfaces have one upper limit, one capacity. They cannot develop more than a limiting value of friction. That's their capacity. They cannot develop more than that value. So the maximum value of phi is attained. The maximum value of phi is attained when friction reaches limiting value mu s into n. When friction reaches limiting value mu s multiplied by n. When the friction reaches maximum value mu s into n, then phi also reaches maximum value. At that time, I can write tan phi s is equal to maximum value of friction upon normal reaction. Maximum value of friction upon maximum possible value of friction upon normal reaction. But maximum value of friction is how much? Maximum value of friction is mu s n. So mu s n upon n becomes mu s. This maximum value of friction angle is known as angle of repose. This maximum value of friction angle is known as angle of repose. So do remember, angle of repose can be obtained if coefficient of friction is known, and if coefficient of friction is obtained if angle of repose is known. Angle of repose and coefficient of friction are like complementary information to each other. Sometimes examiner doesn't give mu s. Sometimes examiner gives angle of repose only. Sometimes examiner is going to give you angle of repose only. So my dear friends, we now know that we have these two important observations. After these two important observations, then we moved on to two important problems. And these two important problems are problem number one. These two important problems are problem number one, that minimum force required to move the block of weight W, up an inclined plane theta, up an inclined plane, up an inclined plane theta would be how much? It would be P is equal to W tan phi s plus theta. P is equal to W tan phi s plus theta. Minimum force required to move a block of weight W up an inclined plane of angle theta. Minimum force required to move a block of weight W up an inclined plane theta would be obtained as W tan phi s plus theta. And then we did one last thing. What will be the minimum force required? What will be the minimum force required to move the block down the plane? What will be the minimum force required to move the block down the plane? Move the block of weight W down the plane. Move the block of weight W down the plane, down an inclined plane theta, down an inclined plane theta would be how much? It would be how much? It would be, we proved it. Array, we solved both these cases. Would be how much? It would be tan phi s minus theta. Phi s is just another way of expressing coefficient of friction. Angle of repose is just another way of expressing coefficient of friction, and coefficient of friction is just another way of expressing angle of repose. So if there is a block of weight W and you want to move that block down the plane, if there is a block of weight W and you want to move that block down the plane of angle theta, down the plane of angle theta, my dear friends, the force required is going to be this much. To move the block up an inclined plane, the force required is going to be this much. Third important observation, please do remember friction angle and particularly max value of friction angle. Please do remember friction angle and particularly do remember max value of friction angle. So now I know all these things needed to understand power screw. Now I know every surrounding concept, every prerequisite. Good evening, good evening, good evening, Bajpayee ji. So now I know every prerequisite that I needed for understanding power screws. Now we are ready. Now we are ready to attack the concept of power screw. Let us go ahead and attack it. So observation number 1, observation number 2, observation number 3, observation number 4, all these observations. By the way, this last formula has a restriction. This last formula has a restriction that this last formula is valid only and only and only and only if the inclined plane angle is only if inclined plane angle is less than tan inverse mu. If inclined plane angle becomes equal to tan inverse mu, then what will happen? If inclined plane angle becomes equal to tan inverse mu, if inclined plane angle becomes equal to tan inverse mu, what will happen? If inclined plane angle becomes equal to tan inverse mu, what will happen? If inclined plane angle becomes equal to tan inverse mu, then block doesn't need any force to move downward. Its weight will move it downward. Then block doesn't need any force to move it downward. Its weight itself is going to move it downward. Its weight is enough to move it downward. So there is a condition in this last formula. There is a condition that angle of inclined plane is not crossing this value. Angle of inclined plane is not crossing this value. Cool. So cool, we have done everything. Okay, there is just what we have solved both these problems, problem number 16 and problem number 17 in one way, but there is just one more way to approach them. There is just one more way to approach them. And before I introduce power screw to you, before I make you get introduced to the power screw, I just want you to understand that one more approach. Please understand that one more approach. So we have already done these two cases. We've already done these two cases. Number one, minimum force required to move the block of weight W up an inclined plane theta would be this much. We have already solved it in one way. This one I'm minimizing right now. Later on, I will bring it back to the live. So I'm just, I'm just minimizing it and putting it over a corner. Before we finally make power screw appear, let's just do this in one more way. How did we get this result? We got this result using free body diagram that we have applied P and weight W will be acting and normal reaction of inclined plane will be acting and normal reaction of inclined plane will be acting. And since block is having upward tendency to move, friction will be acting down the plane. Since I just want to move the block, since I want to just move the block, so since I want to just move the block, so block is going to experience limiting friction in this condition. Then I simply balanced all the forces in X direction and I simply balanced all the forces in Y direction. I balanced all the forces in X and I balanced all the forces in X and I balanced all the forces in Y. And once I balanced all the forces in X and Y, I got this result. So far we have approached this way. I balanced all the forces in Y and I balanced all the forces in X and we got these results. W tan phi s plus theta. we got these results. But there is one more way to solve this same problem. And that one more way is 3/4 principle. 3/4 principle? No, 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 no. 3/4 principle. How can you use 3/4 principle? Sir, hello. I can count 1/4, 2/4, 3/4, 4/4. And since there are 4 forces, how are you using 3/4 principle, huh? There is no 3/4 principle because 4 forces are acting. No, I know that 3 forces are acting, and believe me that 3 forces are acting. So believe me, 3 forces are acting. No, 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 no. 4 forces are acting. One is this horizontal force we applied. Another is the force. One is this horizontal force we applied. Another is the normal reaction. Just wait a moment. I need to put my device into charging because now it has given me a signal that I'm exhausted. So one force we applied, and then there is weight of the block. Since we are trying to move the block up the plane, friction was acting down. And of course, normal reaction on the block by the inclined plane would be acting in a compressive manner away from the surface. So this is how all 4 forces are acting. Now, instead of taking N and mu s N, W I'm going to still take as it is. P I'm going to still take as it is. W I'm going to still take as it is. But instead of taking N and friction force, I will take resultant of N and friction force. So there is this normal reaction acting, and there is this normal reaction acting, and there is this, my dear friends, normal reaction acting, and there is this downward frictional force acting. My dear friends, let's instead of considering normal reaction and friction force, let's consider, instead of considering normal reaction and friction force, let's consider resultant reaction of both of them. So there is normal reaction and there is friction force available. Let's consider the resultant of both of them. And this resultant makes phi s from normal. Angle of resultant from normal is known as friction angle. And since there is limiting condition, we will have that angle becoming equal to angle of repose. Angle of resultant reaction from normal reaction is known as friction angle. And since there is a limiting condition, since there is a limiting condition, my dear friends, that angle is going to be equal to phi s. That angle is phi s. Guys, we are having the angle of W from normal direction as the angle of W from normal direction as theta. This is something I already explained multiple times. Now, tell me whether there are 4 forces or there are 3 forces. There are 3 forces. One is P, another is W, and yet another is, one is P, another is W, and yet another is, one is P, another is W, and yet another is R. Now, angle of R from P will become how much? Angle of R from plane is angle of R from the plane is R is making an angle from the plane, and that is 90 minus 5. In fact, wait, instead of doing this, I already know the angle of R from normal now. That is phi. Angle of R from normal is phi, and angle of W from normal is theta. So can you now calculate this much angle? I suppose this much angle is going to be 1. No. I can calculate P is making an angle. First of all, you draw inclined plane. Unless we draw inclined plane, the picture will not become clear. So let us first draw inclined plane. Now, from normal of inclined plane, R is making phi s. So from inclined plane, R will make 90 minus phi s. 90 minus phi s. And P is making an angle. P is making an angle theta from the inclined plane. So we have theta plus 90 minus phi s. That angle is known. Now, what is the angle between R and P is known. So I can write W upon this. Now, what about the angle between W and R? Because I want to relate P and W together. So I'm going to now, since this angle is 90 minus phi s, and this angle is theta, and this angle is 90 already. This angle is 90 already. So the third angle will be known now. The third angle will be known now. This angle is 90, and the angle between other two forces is 90 minus phi s plus theta. So this third angle will be known finally. And this third angle will become 360 minus this 90. 360 minus first 90, and then second 90 plus theta minus phi s. Cool. Now I can apply Lami's theorem. Lami's theorem says P upon sine, this whole thing, 360 minus 90 plus theta minus phi s, and W upon sine 90 minus phi s plus theta. Sine 90 minus phi s plus theta. 90 minus phi s plus theta. Now this will become 360 minus 90 sine 180. Of course, this is a little tricky method, and that's why initially I solved using sigma fx, sigma fy. Initially I solved it using sigma fx, sigma fy only. Initially I did not approach using this method, but I just want you to have all weapons in your pocket. You should have all weapons in your pocket, isn't it? So P upon sine 360 minus 180 becomes sine 180 and plus theta minus phi s. In fact, I can take minus sign common. If I take minus sign common, I will have phi s minus theta. And on the right hand side, I have W upon sine 90. Once again, I take minus sign common. And if I take minus sign common, if I take minus sign common, I'm going to get phi s minus theta. Sine 180 minus something becomes sine, but sine 90 minus something becomes cos. So sine 180 minus something becomes sine itself. I get sine phi s minus theta. And on the right hand side, sine 90 minus something becomes cos. So that becomes cos phi s minus theta. Now I take this sine phi s minus theta to the other side and I get W sine tan phi s minus theta. W tan phi s minus theta, but I should have got tan phi s plus theta, no? Tan A plus tan B upon 1 minus tan A tan B is
Sir, sir, the direction of power should be in the second quadrant now, sir.
theta is less than tan inverse mu. That's our assumption. Yes. So that way we have done things perfectly. Still, we are getting a mismatched result only by the sign.
Sir, if we look at the
There theta minus pi no, sir.
P is acting horizontal, W is acting vertical, P is acting horizontal, W is acting vertical, and resultant reaction makes an angle phi s from normal direction. So if it makes phi s from normal direction, and then from the plane itself, it will make 90 minus phi s, and this angle becomes theta. So W upon 90 minus phi s plus theta, that is perfect. That is perfect.
Sir, direction of resultant is
Then why the hell are we not getting minus sign common, then phi s minus theta? Moving up the plane, then normal reaction is like this, and friction force is like this. Mu s multiplied by mu s into n is the friction force. I'm just figuring out if I would have taken resultant reaction here, even then result obtained must have been same. 360 minus 90.
Sir, sine
and
180
the other
minus
angle
theta
is
minus
90
pi s no,
minus
sir.
phi s plus theta. There seems to be some input given in chat. Direction of resultant must be in second quadrant. Oh, is it?
yes, sir.
N is acting like this. Ah! Vector sum just committed suicide. Vector summation has just committed suicide, jumping from the 13th floor of an inclined plane. I have actually drawn the vector sum of friction force and resultant reaction as normal reaction. Why, God, why? Don't worry. We are going to immediately get this rectified. So actually, resultant reaction will be the resultant of normal and friction. Normal force is there and friction force is there. So resultant reaction will go like this. This is friction force and this is normal force. And now this is the resultant reaction. So now resultant reaction is making an angle phi s from normal. Let us now draw all these three forces from a point. One force is P applied by us. Another force is W, which is the weight of the block. And third force is making from the normal direction. Third force is making an angle phi s. Third force is making an angle phi s from normal direction, from normal to the inclined plane. So now this resultant reaction is not to be bothered about. This angle is 90 here, and this angle is theta here. So the angle between R and P becomes, 90 plus phi s plus theta. 90 plus phi s plus theta. And the angle between P and W is already 90. The angle between P and W is already 90 degree. And what will be the third angle between R and W? W upon other two angles. I need this angle. So this angle will become 360 and 180 becomes minus. So 360 minus 180, that becomes 180 minus phi s plus theta. 180 minus phi s plus theta. This is the angle between W and R. Now apply Lami's theorem. Apply Lami's theorem, P upon the angle between W and R. The angle between W and R is 180 minus phi s plus theta. And other side you are going to have W upon sine 90 plus phi s plus theta. Sine 90 plus phi s plus theta. Sine 90 plus phi s plus theta. You simplify this, you are going to get exactly the same result. P is equal to W tan phi s plus theta. W tan phi s plus theta. Cool. Now, similarly, the second case can be redone using this concept. Using the concept of three-force principle, the second case can be redone, readdressed. Even though we have done it once, we can just redo it. Second case was, okay, wait. I just need to erase this much, not the conclusion. Second case was the minimum force required to move the block of weight W down an inclined plane theta will be this much. minimum force required to move the block of weight W down an inclined plane theta. And we have already done it using sigma fx is equal to 0, sigma fy is equal to 0. So we have W and we have P and we have normal reaction N acting. And since the block is moving down the plane, friction will be up the plane. Since the block is moving down the plane, friction will be up the plane. So we have already done it using sigma fx is equal to 0 and sigma fy is equal to 0. Sigma fx is equal to 0, sigma fy is equal to 0. ध्यान से समझियो, बहुत ध्यान से समझियो. Sigma fx, sigma fy. And we are done. Now, we are just going to do this same problem in another approach. And that another approach is three-force principle. That you have got this block and then force P you are applying like this and W weight you are applying like this, W weight you are applying like this, force P you are applying like that. Now, there is normal reaction. And if there is a tendency of motion down, then friction is up the plane. And if friction is up the plane, how would normal reaction will act? So we already solved this problem, no? While trying to solve the previous one, we actually wrongly solved this one, roughly. So R is making an angle phi s from the normal. R is making an angle phi s from the normal. And now let us, instead of drawing these forces, let's draw only three forces. Now we know that there are three forces present. One force is W. Another force is the force P that you applied. And third force is the resultant reaction. I repeat one last time that one force that you are applying is one force that the block is having is weight W. Another force we are applying P, and third force is the resultant reaction R. If there is a body under the action of three non-parallel forces, then number one, the forces must be concurrent. Number one, the forces must be concurrent. Number two, that they must obey Lamy's theorem. They must obey Lamy's theorem. This is the resultant reaction. And then there is a force we applied. That force is force P. Perfect. So let us go ahead and apply Lamy's theorem. Before applying Lamy's theorem, we draw the forces away from a point. So this is P acting over here, and this is W acting over here. This is W acting over here, and then this is R, resultant reaction. Resultant reaction is making an angle. Resultant reaction is making an angle phi from normal to the plane. So it will make 90 minus phi from the plane. Resultant reaction is making an angle phi from normal to the plane. So it will make an angle 90 minus phi from the plane. Its angle from normal to the plane is phi. So from the plane, its angle will be 90 minus phi. Can we now calculate all the angles? The easiest angle is between P and W. The angle between P and W is 90 degree. The angle between P and W is pi by 2. This P is acting like this, and this W is acting like this. This W is acting like this, and it is pi by 2. The angle between weight and normal is theta, and then there is 90 degree between normal and tangential of the plane, and then there is 90 minus phi s. So can you calculate the angle between resultant reaction R and the weight W now? Yes, we can calculate this angle easily. This angle will become theta plus 90 minus phi s. Theta plus 90 plus 90 minus phi s. Theta plus 90 plus 90 minus phi s. Now, ध्यान से समझियो, third angle you can calculate. अभी आप तीसरा एंगल कैलकुलेट कर लो बेटा. क्या होगा तीसरा एंगल? This is resultant reaction R. क्या होगा तीसरा एंगल? Naturally 360 से इन दोनों को माइनस कर दो. Just subtract both these things from 360. So if I subtract both these things, this angle is 180 plus theta minus phi s, and this angle is 90 degree. This angle is 90 degree. So 90 plus 180 will get subtracted from 360. So it will become 90 only. And theta minus phi s will be subtracted. So their signs will change. Theta was positive, it will become negative. Phi s was negative, it will become positive. Now apply Lamy's theorem. Lamy's theorem says that P upon the force between the angle between other two forces, P upon the angle between other two forces, the angle between other two forces is 180 plus theta minus phi s, 180 plus theta minus phi s is equal to W upon the angle between other two forces. W upon the angle between other two forces. What is the angle between other two forces? The angle between other two forces is 90 plus phi s minus theta. So sine 90 plus phi s minus theta. Cool. If you simplify, you are going to get W tan phi s minus theta. W tan phi s minus theta. And that's it. We are done with power screw. That's it. Frankly speaking, we are done with power screw. Good evening, Manish. So we are actually done with power screw. If you have attended this session so far, power screw is done. No, how power screw is done? Believe me, power screw is done. Power screw is done. Power screw is done. Why and how? You will realize just now. You will realize immediately. My dear friends, let us read these two observations one last time before we understand power screw. Before we understand power screw, let us read these two observations one last time. The minimum force required to move the block of weight W up an inclined plane theta would be W tan phi s plus theta. Would be W tan phi s plus theta. And the minimum force required to move the block of weight W down an inclined plane, the minimum force required to move the block of weight W down an inclined plane would be W tan phi s minus theta. Read these two important observations one last time before I introduce you to the power screw. And once you have read these two powerful observations one last time, minimum force required to move the block of weight W up an inclined plane would be W tan phi s plus theta. And minimum force required to move the block of weight W down an inclined plane, W tan phi s minus theta. Then we are ready to understand power screw. Let us now understand what is a power screw. Let us now understand what is a power screw. And how does this work? So we have got one rod, and that rod, my dear friends, is having a thread like this. Of course, the rod is further visible. The core dia of the rod is further visible. The core dia of the rod is further visible. And then another thread starts. Then starts another thread. बहुत ध्यान से समझियो. बहुत ध्यान से समझियो. And then starts another thread. And then ends another thread. Then the rod is going to be visible a little more, and we are going to have yet another thread starting, and we are going to have that thread having certain width. Then the rod is visible yet again, little bit. And yet another thread starts. And let's say that's the end of the story. Let's say these many threads are there. Now, something that you see in front of your eyes is the power screw. It's actually fitted in the internal threads of some kind of frame. It's actually fitted in the internal threads. There is internal thread of some kind of frame, and this whole thing is fitted in that, like you can imagine like this, that there is, you can imagine like this, that there is a frame, there is a frame, there is a frame, there is a frame, and that frame is having internal threads into which this screw is fitted. This screw is actually fitted into the internal threads of a frame. Now, suppose there is a weight kept over the screw. If somehow the screw is rotated with the help of a lever or something, so there is a lever here, and we are applying a force at the end of the lever. If using that force, the screw is rotated, what will happen to the weight? If using that force, the screw is rotated, what will happen to that weight? Naturally, the weight can be lifted by rotating the screw in anti-clockwise sense, looking from top. Looking from top, if we rotate the screw in anti-clockwise sense, the weight will keep moving up. And if we looking from top, if we rotate the screw in, clockwise sense, then the weight will be lowered. Power screw is a very powerful invention, very powerful mechanism, very powerful device that can be used to raise or lower very heavy loads like the screw jack of a car. Like the screw jack of a car. Power screw is a very smart device that doesn't require a very powerful machine, that doesn't require any fuel, that doesn't require any electricity. You just move that lever and screw will keep sliding over internal threads of external frame. As the screw will keep sliding, it will also keep moving up. Imagine, visualize that how this screw is going to move up over an inclined plane. This white inclined plane is actually the internal threads of the frame. So those internal threads of the frame behave like an inclined plane. Those internal threads of the frame behave like an inclined plane. And my dear friends, that internal thread behaves like an inclined plane. You visualize that internal thread onto which the screw is moving. This white thing is representing that internal thread, and this is an inclined plane over which W weight of the screw is moving. The problem becomes exactly the same. The problem becomes exactly the same. When you try to raise the load, it becomes observation number 1. When you try to lower the load, it becomes observation number 2. So you already know the results. Horizontal force needed at mean radius of the screw. Horizontal force needed at mean radius of the screw. There is inner radius, inner dia, there is outer radius. And we assume that everything is happening at mean radius. So there is inner radius and outer radius. And we already know horizontal force needed at mean radius of the screw. Horizontal force needed at mean radius Rm to raise load W will be W tan phi s plus theta. How do you decide this theta? That theta is called as lead angle of the power screw. The theta that was earlier the angle of inclined plane, that theta is called as lead angle of lead angle of power screw. I repeat once again that theta is called as lead angle of power screw. Similarly, horizontal force needed to at mean radius Rm, horizontal force needed at mean radius Rm to lower the load. Horizontal force needed to horizontal force needed at mean radius Rm needed at mean radius Rm to lower the load W would be how much? It would be tan phi s minus theta, where theta is what? Theta is lead angle of the screw. So today we call it a day. Today we are done with this much. In the next class, we are going to solve problems. In the next class, we are going to solve problems based on power screw. We will also study efficiency of the power screw. We will also study efficiency of the power screw. We will also study self-locking of the power screw. All these things we are going to study in the next class. Chalo people, see you. Goodbye.
Sir,
If there is anything that you want to ask, go ahead and ask.
sir, sir,
If there is anything you want to ask, please go ahead and ask.
sir,
Hello, friends.
sir,
Any doubt? Any concern? Any query?
sir. Hello, sir.
Okay. Our voices are not getting you. Okay. Is it the case? Okay, okay, okay. I'm so sorry. Actually, when I streamed this to YouTube, then I just switched off the speaker. Okay, then. Let's call it a day. Just in case, if you have any doubt, anything, you can raise it to the group and you can also call me. Cool. I have explained each and everything twice. So I have another session at 7, which is strain energy. Yes. See you guys then. Bye-bye.
Sir.